Hi, can you hear me?
Hello?
Yeah, you can hear me, right?
Yes.
Okay, so today's class we'll just do some practice problems for your pure math paper. Okay,
Okay.
so I'm assuming that you have almost finished your theory, like whatever syllabus you had to do, you have already
Yeah.
covered those chapters, right?
Yes.
So we can do questions from any topic, correct?
Yes. Correct.
Okay, so right, so first question is this f of z is given by z power 4 minus 14 z cube, z power 4 minus 14 z cube minus 78 z square plus kz plus 221 minus 78 z square plus kz plus 221. Now they have told us that z is equal to 3 minus 2i. Z is equal to 3 minus 2i is a root of f of z equals 0.
Okay.
You, uh are you saying
Uh,
something?
yeah. Yeah, that makes sense.
Now you have to show that z square minus 6z plus 13, show that z square minus 6z plus 13 is a factor of f of z. You also have to find the value of k, and third part is basically find all the roots of f of z equal to 0. Find all the roots of f of z equals 0. So the easiest part here is which one? Easiest one
Uh,
will be this.
yes. Because
What do you have to do for that?
uh, we could substitute
Hmm.
z equals to 3 minus 2i.
You substitute z is equal to 3 minus 2i. Since this is a root, it should become 0, right?
Yes.
So you do 3 minus 2i to the power 4 minus 14, 3 minus 2i to the power 3 minus 78, 3 minus 2i whole square plus k into 3 minus 2i plus 221 equals 0, right?
Yes.
This will give us a complex number equals 0, and we can say that the real part and the imaginary part of it will become 0,
Yes.
right? So,
Right?
actually, however, calculating this might be a little annoying, right?
Yeah.
So, like ideally, you would want to avoid trying to calculate power 4, power 3, and 14 and
Yes.
78 is there, right? So, you have
Right?
to think of a smarter way to do it. So, that's why they have asked you to do this first. Do you understand what I'm saying?
Yes.
So, you should think of a better way to do this problem. There is a obvious way to find k that we know, but can we do it in a different way?
Uh, we can.
You have to show that this is a factor, right?
Yes.
How do you show that?
Uh, that um if we substitute in, or we could use polynomial long division.
What do
But
you
also,
mean? That has already assumed that you are assuming that it's a factor.
uh, uh, to
You
prove
have
that
to
it's a
show
factor
that it's a
is
factor. Yeah. How? How do you do that?
then that means that uh, if we sub in the negative of that into
Negative
the
of what?
equation, z squared minus 6z plus 13, then
What do
it
you
should
mean?
be equal to 0.
What do you mean negative of that?
Oh, uh, I mean, if we equate that to 0, then the values of z that we get should be roots of the equation.
What are the values of z that will be roots of this equation?
So we'd have to use quadratic formula. So it would be 6. Yeah, 3 plus minus 2i.
Can you see now what is happening?
Yes,
3 minus 2i and 3 plus 2i are both going to be roots of this, right?
right, yeah,
Because this is a factor. Like, in order to show that it's a factor, we'll have to put 3 minus 2i into it and show that it is 0. And you'll also have to put 3 plus 2i into it and show that it is 0, right?
yes,
If you show that, then that means that z square minus 6z plus 13 is a factor of f of z. Correct?
uh, correct,
Okay, so it feels like you have to calculate it because in order to
yes,
prove this, you will have to calculate it out and all. So that is not difficult. So I will not ask you to do it right now because it will be a waste of our time. But suppose we have done that, we have shown that after putting z is equal to 3 minus 2i and 3 plus 2i, f of z is 0. So part A is done. And from there you can also find k when you put 3 minus 2i, right?
yes, right,
So once you do that, uh, oh, 1 second. If you put 3 minus 2i, you don't know k, but now we know that it vanishes for, it should vanish for 3 plus 2i also, right?
yes,
So if it vanishes for 3 plus 2i also, right? Basically, you'll get an equation like this and another equation involving 3 plus 2i, right?
yeah,
Right. So, yeah. So from there, you can find out the value of k, and that k will be such that the other one will also be a root. Do you understand what
yes,
I'm saying?
yeah,
Okay. Right. But it is quite long though, doing it, right?
yeah, I
The
will take
solution
too
will
long.
take some time. I cannot think of a method that will be faster right now. So maybe you are expected to do all this. So, okay, let's go to the next problem. Is it clear what you have to do here? You know what has to
Yes,
be done. Okay, let's
yes.
go to the
So
next
for
problem.
part, yeah,
Were you saying something?
I was saying for part C of that problem, you just use Uh,
Right. Once you know the roots, you can divide, right?
yeah, this is polynomial long division with both of the roots that you already have.
You already know this is a factor. You divide, you'll get a quadratic, and again another quadratic
Yes.
term. And from there you
And
can
then,
find the other roots,
okay.
right? Okay.
Yes.
So the next question is the cubic equation. The cubic equation 2x cube minus 3x square minus 7x minus 1. 2x cube minus 3x square minus 7x minus 1 equals 0 has roots alpha, beta, gamma. Now, without finding the roots, without solving the equation, we have to find a cubic. Find a cubic with roots 2 alpha minus 1, 2 beta minus 1, 2 gamma minus 1. And you are not allowed to find the roots. You don't have to solve the equation, but you have to find a new equation.
Okay. So,
You know the concept of transformation of equations?
yeah.
Like from a
Uh,
given quadratic with roots alpha, beta, you should be able to find a new quadratic with roots slightly different behavior of alpha, beta, right? A transformed
yes.
version of alpha,
Uh,
beta. It's the same principle that you have to apply here.
so,
Do you know what you're supposed to do?
no, I'm actually not sure.
So pay attention. This is very important. It's not like
Okay.
it's an important concept. So if I have this equation has roots alpha, beta, gamma, obviously I have equations like this which are valid, right?
Yes.
Right. So this equation is true. Similarly for beta and gamma also, right?
Yes. Right.
Now let's say I need to make a new equation, but I need the roots to be 2 alpha minus 1, 2 beta minus 1, and 2 gamma minus 1, right?
Right.
So what I will say is if x is equal to 2 alpha minus 1, y is equal to 2 beta minus 1, or the roots are such that they are 2 alpha minus 1 and all, what we are trying to do is find alpha in terms of x. So find alpha,
Yes.
we'll get x plus 1 by 2, right?
Yes.
And we know an equation where alpha is there, right? We will
Yes.
put instead of alpha, now we'll put alpha is x plus 1 by 2. Do you understand what I'm saying?
Yes. Understand.
This will give us a new equation that will be in terms of x, right?
Yes.
That will be a new equation that will be satisfied by this x, right?
Yeah.
The point is that if you have a quadratic, let's say ax square plus bx plus c equals 0, and we know alpha plus beta is equal to minus b over a, and alpha beta is equal to c over a, and alpha beta are the roots, right?
Yes.
Now
Right.
you might have a new function y is equal to some function of alpha. Let's say it is p alpha plus q. right?
Yes, right?
I want the equation to have roots y, right? P alpha plus q to be the roots, correct?
Okay, correct.
So what can I do? I need a new equation with roots y, right?
Yes,
So I have an old equation. In the old equation, I can already see that a alpha square plus b alpha plus c is 0, right?
yes,
Now, all I need to do is look at this relation and solve for alpha in terms of the new variable, right?
yes,
I'll say alpha is equal to y minus q over p, right?
right.
And I can put
And
that
then,
in this, and I will get a y minus q over p whole square plus b y minus q over p plus c is 0. And notice that after simplifying everything, this will look like a quadratic in y,
yes,
and it will be equal to 0, which means y is a root of that quadratic, right?
yeah,
Let's say after simplifying everything, all of these are constants, by the way, right? These ones.
yes,
After simplifying everything, it looks like a y square plus capital B y plus capital C is 0, right?
yes,
So obviously then we can say that in the equation ax square plus bx plus capital C equals 0, y is a root, right?
yes, right?
Do you understand what we are saying?
Yes,
We started off with one normal equation where alpha was a root, but now we have a new function of alpha. I need to make this thing a root, right? So I'm calling
yes,
it a variable y is equal to this, and I'm finding out alpha in terms of y, and I'll put that in this, right? And then I will end up with an
yes,
equation in y, and I can say that the new equation has y as a root. But y was equal
uh,
to p alpha plus q, so you have converted the original equation into a new equation.
yeah, okay,
So in this problem, for example, we have 2x cubed minus 3x squared minus 7x minus 1, 3x squared minus 7x minus 1 equals 0. We know alpha, beta, gamma are the roots. All the other roots, the new roots that I need are also in the same way. Obviously, the method won't work if one root is like this and another root is something else.
yes,
This method only works if you apply the same transformation to each of the roots. Do you understand?
okay, yeah,
It can't be
understand.
that I can change only one root and I'll leave the other roots as it was. That is not possible. Correct?
Yes,
So,
correct.
what we are saying is this is true, 2 alpha cube minus 3 alpha square minus 7 alpha minus 1 equal to 0. Now, my new variable, however, is y is equal to 2 alpha minus 1. So, obviously, I need y to be a root, right, of a new equation.
Yes,
So I will say y plus 1 by 2 is equal to alpha, and I can put that in this equation of alpha. So I'll get 2
uh,
by 8 y plus 1 whole cube minus 3 by 4 y plus 1 whole square minus 7 by 2 y plus 1 minus 1 is 0, right?
yes,
Multiplying that by 8 throughout, you get 2 y plus 1 whole cube minus 6 y plus 1 whole square minus 28 y plus 1 minus 8 is 0. And now let's simplify it out. 2y cube will come. There is a plus 1, so plus 2 plus 3y into y plus 1. So 6y into y plus 1. So 6y squared plus 6y, right? That's the
yes,
first one. Minus 6y squared minus 6 minus 12y minus 28y minus 28 minus 8, right?
yes,
So after cancelling everything, you are getting 2y cube, 6y minus 12y minus 28y. So minus 34y, and Then you have plus 2 minus 6 minus 4 minus 40 is equal to 0. So my equation is y cube minus 17y minus 20 is equal to 0.
Yes.
And
Uh,
now we know that the equation x cube minus 17x minus 20 is equal to 0 has root y, right?
yes.
What was y? Y was 2 alpha minus 1.
Yes.
You
Then you
understand
can,
what I'm saying?
yeah, I
So
understand.
I know that 2 alpha minus 1 is the root of this equation. Alpha was a root of this equation, and I have converted it into a new equation whose roots are 2 alpha minus 1, 2 beta minus 1, and so on.
Yes.
You can apply this principle in any simple question. For example, if you have x square minus 3x plus 2 equals 0, I know the roots of it are alpha beta. I need a new equation with roots alpha cube by 2 minus 1 and beta cube by 2 minus 1, let's say. Looks complicated, but notice that
Yeah.
both the roots are getting the same pattern is happening, right?
Yes. Yeah.
So now I'll say that, okay, I need a new equation with variable y is equal to alpha cube by 2 minus 1. This is my new thing, right? I need y to be a root.
Yes.
Okay, so I can say that y plus 1 into 2 is equal to alpha cube. So alpha is equal to cube root of 2y plus 2, right?
Yes.
Okay, and already I have an equation here, alpha square minus 3 alpha plus 2 is 0, right?
Yes. Right.
In that I will put this, so 2y plus 2 cube root of 1 by 3 power 2, so 2 by 3 minus 3 2y plus 2 cube root of 1 by 3 plus 2 is equal to 0, right?
Yeah.
Now, what you can do is notice that this stuff is there everywhere. So ideally, I want to remove the powers here. So what I will do is 2y plus 2 to the power 2 by 3
Yeah.
uh, is plus 2 is equal to 3 times 2y plus 2 to the power 1 by 3, right?
Yes.
And raise everything to the power 3. So this side it will become 2y plus 2 whole square plus 8 plus 3 into 2 into, by using the cube formula, 3ab. So 3 into 2 into 2y plus 2 to the power 2 by 3. And then sum of this 2y plus 2 to the power 2 by 3 plus 2, right? Is equal
Yes.
to, on the other side, 27 into 2y plus 2, right?
Right. Yeah.
Correct. And now, okay, the equation is becoming a little complicated, but for now, I don't want to simplify it. Let's keep the equation as it is here. I will prove that the
Yes.
equation is correct. We can do that. So let's say this is my new equation, right? So
Okay.
the new equation is 2x plus 2 to the power 2 by 3 minus 3 into 2x plus 2 to the power 1 by 3 plus 2 is equal
Yes.
to 0. This equation has root y
Yes.
because y is equal to, if we put for x, y,
Uh,
that is satisfying, right?
yes.
Okay, and y was equal to this and all. Now look at the original equation. I already know the roots are 1 and 2. So alpha is 1 and
Yes.
beta is 2, right?
Right.
So what are the new roots here? New roots are 1 cube by 2 minus 1, so minus half. And the other roots is 2 cube by 2, so 4 minus 1, so 3, right?
Yes.
This is the new equation. The new equation should have these roots, right?
Yes.
Now you can put minus half in it and see if it's satisfying or not, right? If you put
Yeah.
minus half, you will get 1 here, right? So
Yes.
1 minus 3 plus 2. See, it is 0,
Yeah. That's so it is a root.
right? And let's check whether 3 is a root or not. See,
Uh,
8, 8 to the power 2 by 3 is becoming 4, right?
yes,
4 minus 3 into 8 to the power 1 by 3 is 2 plus 2.
yes,
Do you see that even if it looks horrible, this is still having roots these?
yeah,
After changing it, even if it looks horrible, we have not even made it a polynomial equation yet. It will take a lot of effort to make it a proper polynomial equation. But the
yes,
transformation method will work. Do you understand what I'm saying?
yes, understand.
So you need to know that method. You should try questions on that. It might be somewhere in your book. There might be problems on that.
Okay,
Okay, next question is a plane has a Cartesian equation x minus 2y plus x minus 2y, no, x minus y plus 2z equals 3. X minus y plus 2z equals 3. You have to first find a unit vector n normal to the plane. Find a unit vector n normal to the plane. Second, a line L has the vector equation. A line L has the vector equation R vector is equal to 0, 3, minus 1 plus lambda times 2, 4, minus 3. Line L has this vector equation. The line intersects the plane at point P. This line intersects the above plane at point P. You have to find P. Find
yes,
point P and find the
okay,
angle between the line and the plane. Angle between line and plane. So if you know your concepts of 3D geometry, you should be able to do this. It's not difficult.
yes, okay.
Vectors in 3D. What is part one? How do you find vector normal to the plane?
Will be equal to uh the coefficients of the plane. So
Hmm.
like
1, -1, and 2.
yes,
The vector would be I, 1i minus 1j plus 2k, but you have to make it a unit vector, right?
yes.
Because this vector doesn't
So
have length 1, right? The length of this
yes,
vector is actually 2. Length of this vector is 1 square plus 1 square plus 4. Actually, it is 6, root
uh
6.
the square root of 6. Yeah.
So to make it a unit vector, you'll have to do 1 by root 6 I minus 1 by root 6 j plus 2 by root 6 k. That will be the unit
Yeah.
vector which is perpendicular to this plane, right?
Okay. Yeah.
Now you have to find out the point of intersection of this line and the plane.
Okay.
The meaning of the line should be clear the way it has been written. What it
Yes.
means is that it passes through this point and it is parallel to this vector, right?
Yes.
It is like A vector and lambda B vector. It is line is passing through A vector and it is parallel to B vector. Correct?
Yes, correct.
So the line equation can be written as 0i plus 3j minus k plus lambda times 2i minus plus 4j minus 3k, right?
Yes.
This r will give us any point on the line, correct?
Yes.
Any point on the line should satisfy the line equation. So any point on the line, if you collect all the I terms and the j terms and the k terms together, you will get here 0 plus 2 lambda. So 2 lambda I plus 3 plus 4j. 3 plus 4 lambda j, right?
Yes.
And minus 1 minus 3 lambda k. Minus 1 minus 3
Yes.
lambda k. So this is a random point on the line, any point on the line, right? Correct.
Yes. Correct.
This point must intersect the plane somehow. So it should lie on the plane, right?
Yes.
At least whenever the plane intersects the line, there is going to be one point that is common to both, right?
Yes.
So if that point was this, with vector notation given as this, the vector notation of this point is P, then obviously at that point it is also part of the plane, right?
Yes.
So at that point, it will be perpendicular to the normal to the plane, right?
Yes.
Since it is lying on the plane, any point on the plane is going to be perpendicular to the normal vector, right?
Yeah.
So what we can say is at that point, what is the location of this point? It is 2 lambda, comma 3 plus 4 lambda, comma minus 1 minus 3 lambda, right?
Yes.
That vector is going to be perpendicular to the normal vector, right?
Yes.
Normal vector was this, right?
Yeah.
We don't have to make it a normal unit vector. You can just use the normal vector because what matters is that it is perpendicular. And for perpendicular, the dot product of these two should be zero, right?
Yes.
Do you understand what I'm saying?
Yeah, understand? because the dot product has to be 0 because they're perpendicular.
Right. Any point on the plane is given by this. Any point on the line is given by this. We are looking for that lambda value which is perpendicular to the plane normal, right? So that means that
Yeah.
lambda will be such that it lies on the plane, right?
Yes.
So for
Right.
perpendicular, you can say dot product is 0, and therefore take a dot product between this and this. You will get 2 lambda minus 3 minus 4 lambda plus minus 2 minus 6 lambda is 0, right?
Yes.
So we are getting 8 lambda on the other side is equal to minus 5. So lambda is minus 5 by 8, correct?
Yes. Correct.
If lambda is minus 5 by 8, I can find this point now. It is minus 5 by 4 comma 3 plus 4 times lambda. So 3 minus 5 by 2. So that is going to be 1 by 2. And minus 1 minus 3 lambda. So minus 1 plus 15 by 8. So that will be basically 7 by 8. So
Yes.
you are getting the point as minus 5 by 4 comma 1 by 2 comma 7 by 8. Correct?
Correct. Yeah.
So that becomes the point on the plane where the line meets the plane.
Okay.
You can also check by putting it in this equation whether it fits or not, right?
Yes.
Let's check once. Minus 5 by 4 minus 1 by 2 plus 2 into 7, so 7 by 4. So this is becoming, yeah, I have made some mistake then. I feel like I made some calculation mistake because this is not fitting. So I made some mistake.
Yeah.
1 second. So my vector equation was 0, 0, 3 minus 1 plus lambda times 2, 4 minus 3. And the plane equation was x minus y plus 2z equals 3.
Yes.
Okay. So think of this like this: xi plus yj plus zk is equal to this.
Uh.
So 0 I plus 3j minus k plus lambda into 2i plus 4j minus 3k. So we are getting x and y and z, our points on the line will be 2 lambda, 3 plus 4 lambda, and minus 1 minus 3 lambda,
Yes.
right?
Right.
These are my x, y, z random points on the line, correct?
Yes. Correct.
Okay. Now that point on the line should satisfy the equation of the plane, right?
Yes.
Correct. So
Correct.
let's put that into this to find lambda. So we'll say 2 lambda minus 3 minus 4 lambda minus 2 minus 6 lambda is equal to 3, right?
Yes.
Do you understand what I'm saying?
Yes.
See, I was making a mistake earlier because I was taking a point and doing dot product of the point with the normal vector. That's not correct
Uh.
because normal vector should be that point's position is a position vector, no, to the origin.
Yes.
If I wanted to do dot product, I should have done dot product with any line on the plane. No, that is perpendicular, right?
Yeah.
What I got
Yeah.
was the location. Location is with respect to origin, right?
Yes.
So when I said this is dot product with normal is 0, that's wrong. Because this
Uh,
vector is not necessarily perpendicular, right?
yes.
This vector is just telling position of that point with respect to the origin, right?
Yes.
Origin can be somewhere away from the plane somewhere else, right?
Right?
So what I should do is that if I have got the point's coordinate, I need to make it fit the equation of the plane, right?
Yes.
So I will do that now. That is a straightforward thing. I'll put 2 lambda this and this into the equation of the plane. And I'm getting 2 plus 4, 6. 1 second. What am I getting?
Uh,
Minus, oh, 3 plus 4 lambda it was, right? So minus 3
yeah.
plus 4 lambda. So now I'm getting 2 minus 4 minus 2 minus 8 lambda. And this side is minus 3 minus 2. So minus 5. And this goes on the other side becomes an 8. So lambda is minus 1, right?
Yes.
So the point is becoming minus 2 minus 1 and plus 3. So plus 2, right? So this is the
Yes.
particular point on the plane at which the line cuts the plane, right?
Right?
Now, the second part of the question is find the angle between the line and the plane, right? Now,
Yes.
in order to find the angle between the line and the plane, you need the direction of the line and you need the normal to the plane, right?
Yes.
That will give us
Right?
the angle between the line and the normal. The other angle, the 90 minus theta of that would be the actual angle that we need.
Yes.
Do you understand what I'm saying?
You understand?
The dot product of this vector and this vector should give us the theta, which is the angle between the line and the normal. But what we need actually is the angle between line and plane, right? So we need
Yes.
the complementary angle, 90 minus theta. Do you understand?
Okay. Yeah.
So the direction of the line is given by this parallel vector, right? This vector.
Yes.
This is the direction of the line, nothing else is required. The direction of the normal to the plane is I minus j plus 2k. We already know that.
Yeah.
So actually now the dot product of these, if you do properly dot product and divide by the modulus, you will get the cos theta between these two vectors. Correct?
Yes.
So dot product is 2 minus 4 minus 6 divided by mod of root 6, and mod of this is 4 plus 16, 20 plus 9, root 29, right? So we are
Yes.
getting minus 8 by root 6 into root 29. That is equal to the cos theta, correct?
Yeah. Correct?
Okay. That is the angle between the line and the normal. So 90
Yes.
minus that angle will be the angle between the line and the plane, correct?
Yes.
So that is the situation. You can now figure out the rest of it. But the point
Okay.
is, you need to know your plane equation, you need to know how to intersect a line and a plane, things like that.
Yeah.
Those are basic concepts that you need to be comfortable with, right?
Yes.
All this you have tried before in the year, right?
Yeah.
Okay. Uh, the next question is, 1 second. Right. The question says a complex numbers has been done, right, for you?
Yes.
A complex number z has argument theta and modulus 1. Z
Okay.
has argument theta and modulus 1. You have to show that z power n minus 1 by z power n is equal to 2i sine n theta, 2i sine n theta, where n belongs to integers. And
Okay.
the second part of it is saying, hence show that 8 sine power 4 theta, 8 sine power 4 theta is equal to cos power 4 theta minus 4 cos 2 theta plus 3. Cos power 4 theta minus 4 cos 2 theta plus 3. So you have to use this first and then use that to try to do this. Don't try to prove this directly.
Okay.
You know the meaning of argument and modulus of complex numbers.
Yes.
Okay, so use that.
Okay.
What is z power n?
Uh, Z power n would be 2i sine n theta plus 1 over Zn.
You have to show this. What are you trying to do here?
Oh, uh,
This is not a relation that is given. You have to prove it.
okay. So if we drew it on a organ diagram, the angle would be theta and the length, the magnitude would be 1. Then uh,
Okay, you have not studied complex numbers, at least recently it feels like. Your revision is not there. This is not so difficult. It's super obvious if you revise the chapter. It's there in the syllabus, right?
Yes.
You don't know about Euler's formula or de Moivre's theorem.
No.
You don't know that e power I theta is cos theta plus I sin theta.
No.
That's basic. You need to know it.
Okay.
Find out about Euler's formula and de Moivre's theorem. These are there in the AOPS books also. You should be having, you should have seen them already. This is not something new. This is not the first time you should be seeing it. If you're doing complex numbers without this, you can't do anything. So go back, find it where it is in your book, or find it in the AOPS books in the complex numbers chapter.
Okay.
In the AOPS volume 2 or volume 1, it is there. So figure it out and revise complex numbers because it doesn't feel like you know what you have to do here. Tomorrow's class will be
Okay.
Olympiad, so we'll be doing the chapter 5 of AOPS book and we'll try to finish that chapter tomorrow. So come prepared for that.
Okay.
Okay, that's all for now.